I would like to share some results from the study of Typhoon Morakot. And in this study, we used the radar observation to document some interesting, unique aspect of the orographic preset associated with this typhoon event. And most of this research work has been done by student Cheng and in the past few months. Okay, when considering the typhoon environment and when considering the typhoon environment, the high wind speed is usually occurred near typhoon. And in this situation, we can get a larger full number. And actually, because the incident flow is usually very strong, so we can get a full number easily much greater than 1. So in this large full number flow regime, and we can expect the incident flow will climb over the mountain instead of the falling around the mountain. Okay. So the importance of the wind wall enhancement has been generally recognized by a large number of the previous typhoon-related studies. However, the definition of the wind wall size would be kind of ambiguous, especially for a highly three-dimensional topography feature. And this figure just give you an example. This is the topography feature over the region of heavy precip associated with Morakot. And this is southern central mountain ridge. And given the incident wind is generally from the west to east, so we can, if we consider this spot, we can see this spot is a wind wall side for the southern central mountain range. However, for this local small-scale terrain, this spot may be considered as the lee side. So the wind wall side enhancement is kind of the very, is sometimes very vague for a three-dimensional complicated topography feature. In addition to the importance of the wind wall side enhancement, and two recent studies. Sorry. Okay. Two recent studies by Cheng 2008 and Smith et al. 2009. These two studies proposed that the cedar feeder mechanism, okay, may be very important in generate the orographic enhancement, okay, through the so-called cedar feeder mechanism. And in this context, the typhoon background precipitation may be considered as a so-called the cedar cloud, and the orographic generate hydrometer can be considered as a feeder cloud. So as the precip particle falling through the feeder cloud and the hydrometer will grow through the collision and correlation process, so some orographic enhancement can be observed over the mountain area. Okay, so this kind of the process may be very important, especially for the considerable. We can get some considerable typhoon background preset. So this is I think this is the case for Morakot. Okay, this is an animation of a radar echo for Morakot. Okay, and you can see the very abundant, considerable the upstream precipitation echo. Okay, over here, and propagate from ocean to land in the mainland fall over the mountain area. Okay. So for this particular case, we can expect that the cedar feeder mechanism may be also very important. Okay. So what can we learn from Morakot? Okay. We can document the detailed distribution of orographic preset over the complicated and the three-dimensional topography feature. And the second, we can try to identify the orographic enhanced process in the presence of the abundant typhoon background precipitation and the strong persistent oncoming flow. The third, we may be able to identify the relative contribution of the orographic forcing and the typhoon background precip. Okay, this figure just shows you some the study domain and the data resources we use in this study. And the primary data set is the Cheng-Ku radar and the Candy radar from the Central Weather Bureau. And especially for the Cheng-Ku radar, because this radar site is very close to the region of the heavy precip for the Morakot. So this radar is very important, can provide very better coverage, okay, for the rain information over the mountainous region. We also performed the dual double census over this region, and so this can provide us some very variable wind information just upstream of the Taiwan landmass. Okay. So because our focus is on the orographic precip, so the processing of radar major on nearby mountains must be very careful. So we need to do some kind of identification of beam blockage and the removal of mountain and ground cutter. And we also need to remove the radar echo with high altitude above the ground level. In this study, when the radar beam higher than 2 kilometers above the ground, we just remove it. Because if I think including this higher altitude radar echo will cause the significant underestimate, okay, for the rainfall. If the the orographic enhancement was confined very shallow layer very close to the ground. Okay. So this so with this procedure we can obtain the lost available level of reflective data, and we use this information to mapping the low level rain information. Okay, before go to detail for the distribution of orographic precip, we just give you some idea about the overall the precip situation associated with the Morakot. And this is the reflectivity as a function of time and the distance of the major mountain barrier. Okay, and this is the reflectivity has been projected, okay, onto a section normal to the mountain barrier, and this time is over here, and the DC and this land, and we can see the most of pronounced precip was over the ocean, okay, just mentioned by the Professor Joe earlier, and however overland the precip intensity